We're talking about classes and objects today, and we're going to do so by reviewing this example. I do apologize that some of the lecture was cut off because I forgot to press record. So there are other materials posted that should help you get through that. I might post last semester's. I don't know. I'll have to decide if I want to post last semester's lecture as well, along with this one. Now I'm shook. All right, but anyhow, we'll continue. I'll tell you what, I will only post this part of the lecture. I won't post last semester's, but I will post other examples of the kinds of stuff that I talked about in there. And if you have any questions at all, by all means, ask. So here we have a class. And as we said before, a class has attributes, which are characteristics of the class, and there are methods, which are functions. Now, here's how we define a class. It's in a file called pizza.java, and it's called pizza. Here are the attributes. Notice these attributes are declared outside of any function. They're right after the class definition. That means that they can be accessed anywhere in any function within the class. I have a designation of private in front of these. For now, every attribute we create is going to be private. I'll briefly go over why that's the case. But if it doesn't make sense to you, remember to make them private and you'll be okay. We make them private so that we control access to them. For example, the sizes of pizza for my company, let's say, is small, medium, and large. S, M, and L, let's say. The kinds of crust are thick and thin. Well, at some point, I'm going to put code in this function to make sure that I only give the pizza a valid size. I'm not going to let anyone just assign any value that they want to that size attribute. I'm going to write code to control that, and it's going to exist in a method. When you think of having code to do something, think of that's having a method to do something. All right? Private means that this could only be accessed by the methods in this class. Other classes cannot access these attributes directly. Right? And we'll see what that means in a couple minutes here. How do you access these? You access these by set and get methods. A set method takes an argument and sets that variable to the value of the argument, and a get method returns that value. So when I create a pizza, and we'll see how to create a pizza when we get to the unit test object. When I create the pizza, if I want to assign that pizza the size of large, I will do that by calling the set size method. If I want to call or set the crust to thin for this pizza, I will call the set crust method. I cannot access these things directly. Likewise, if my code needs to know what the size of the pizza is, I'll use the get method. So this is used to, these methods, the set methods, are used to assign the attributes a value. And we need them because we do not want to let the outside world, other classes, directly manipulate those attributes. All of these are going to look the same, all of these methods. We have the word public. So most of the methods we're going to create for this class are going to be public. That means other objects can access this. Other classes can access this. As compared to the attributes, which by making it private, other classes cannot access. Void means that this function does not return a value. You don't see the word return after this. The name of the set function is going to be the word set in lowercase and the name of the attribute that's capitalized. Remember, we use this so-called camel case to use the lowercase letter of the first word, an uppercase letter of each subsequent word. It's going to take one argument, this function. Remember, an argument is a value that you give a function to do its thing. And that function is going to take that argument and put it in the attribute name size. It's a very important thing to understand because all these set statements look the same. The only difference between them is this one's for the crust, this one's for the has pepperoni boolean, and the arguments are string, because these attributes are defined as string, and this attribute is defined as string, and this one is defined as a boolean. Otherwise, it's a formula almost. Function is going to be public, it's going to be void. The set function is going to be set in the name of the attribute. It's going to have one argument, that's whatever type the attribute is, and it's going to take that argument and assign it to the attribute. Very straightforward. This will always be the case. Now, what might be different later on is we might put validation rules in here. Like if they don't, that make sure, gee, it has to be small, medium, or large if you're going to set the size. We're not worried about that today. We're going to pretend that everyone plays nice and follows the rules, which is, I know, a dangerous assumption for the real world, but for the second day of class, that's okay. Right? Yes.
Does the actual defining come in, like the small, medium, large, or the type of crust that you're choosing?
In other words, the fact that it's small, medium, and large are the three choices.
Yeah.
I probably should comment and say that. So, acceptable values are small, medium, and large. That's probably the best you can do right now. Later on, we're going to study something called enumerations, and that's where you really define those values. But we're not ready for enumerations yet. So for now, we're just going to make them plain old strings, and we're going to have in comments what we're supposed to have, and we're going to make sure we follow the rules. Great question, though. We then are going to have these get methods. And these get methods do the opposite. They return the value of attributes. In other words, you can use a set to set the size of the pizza. You can use a get to return what size it was set to. These are simply public functions that return whatever type the attribute is. They say get and the name of the attribute, and they simply return the value of the attribute. Now, those of you who've done, if you've done anything like this in C#, if you've done classes, which I'm not sure if you do in 160 or not, but C# does this, C# sort of hides you from this. Java, one complaint about Java is that a little bit of the code is bulky. In other words, for every attribute you need to get in a set. All right. Now, the good news is that they're not hard to create. Once you've done a few, they're real easy to create. The bad news is you still have to create them. You still have to go through the trouble of creating them. Whereas there's a way in C# that sort of does the same thing that we want to do, but does it in a more streamlined way. I don't want to say simpler, but I'll say more streamlined. All right. So these are the kinds of methods that I talked about in that first screen that like, well, there's a bunch of other methods that we'll talk about later. Well, now is later. All right. These are the bunch of those methods. We then have a calculate bake time. It simply looks at the bake time, and we have two options. Either bake time for thin crust is 10, the bake time for everything else is 16, and then we return the value of the bake time. Notice to compare it, you do not use double equals for comparison. And we'll talk about that later on, why that's not good. The way you do it is with the equals function and say, does crust dot equals thin? That's effectively the same thing as saying, does crust equal thin? So this is our template for pizzas. This is everything that we know about pizzas in our system. Like I mentioned before, later on, you're going to have other methods. Calculate calories, calculate how much it costs, and maybe some other things. All right, but right now, these are all the methods and attributes that we have. Now, we've defined a template for pizzas. Notice there's no main method here. So we cannot run this pizza class by itself to see if it works, because there's no main method in here. We could put a main method in there, but that wouldn't be a good idea. Instead, we're going to write what's called a unit test. And a unit test tests an object or maybe a group of objects and make sure they function the way they're supposed to. You can think of the unit test, as I said before, as sort of replacing the GUI. And this is what it looks like. This does have a main method, like we saw last week, so we can run this object. All right. Critical statement right here. Pizza P1 equals new pizza. Let's break this statement down. Spread this out. So underneath it, I can put so that's what the first pizza means in here. It means that the object I'm creating is of type pizza. Now in Java, we can do something like this. All right, and say int x equals 0. And we don't have to go through all this stuff over here. In a way, it's serving the same function. Here I have an integer. I'm going to call that integer x, and I'm going to set the value to 0. However, because these involve objects, we have to do more work. So in both cases, this specifies the type of the variable that we're dealing with. This is the name of the variable. It's going to contain that integer. P1 is the name of variable or object. Equals, of course, is the equal sign. And what that means is what we, put the right side in the variable. Well, we all know what the equal sign is. I'm not going to talk about that. It's assignment. We're going to figure out whatever this is, and we're going to put it in that variable named P1. Just like we're going to figure out what's on this side of the equal sign, we're going to put it in the variable named x. So, what does new mean? New means create an object. And what kind of object? Well, we're going to create a pizza. Very often, this is going to match this. In fact, until we study inheritance, this is always going to match this. Because we're going to create it in pizza. We're going to create a new pizza. We're going to store it in a variable. That contains a pizza. So this is a variable that's a pizza variable. And we're going to store the new pizza we created in that variable. Now, so we create our new pizza. Now I'm going to call those methods and give those methods the values that I want to give. So I set this pizza to L. So I set size to L. What does that code do? It calls the set method and takes whatever I've passed it, in this case the variable L, and puts it in the attribute name size. When I create that object, these all are empty. These all have no values in it. And we then are now going to give it a size of L. We do the same for the kind of crust. We do the same for whether it has pepperoni or not. I can then call the get methods to return the values that were set, and I can call the calculate bake time method to do the calculation, and depending on whether it's thin crust or not, give me a different answer. And I did this with 3 pizzas. Very often when we do our testing, we're going to have more than one object that we're creating because we want to test for all possibilities. Right now, the 2 possibilities that are relevant to calculating the bake time are simply whether the kind of crust that it has. So I'm testing both thick and thin crust. So I'm doing an okay job of testing. So now let's run this. I'm going to do my Java, C, and I'm going to compile unit test. .java. Notice that my class name was unit test with a capital U and a capital T. And therefore my class is named unit test with a capital U and a capital T. I can compile that. Here's a neat thing about Java. When I compile it, because the unit test class uses the pizza class, I don't have to compile the 2 classes separately. So compile your unit test class, now we'll compile everything. If I look, now now it shows me the classes along with the source code. And I can run it just by running Java unit test. And goes in here, and first pizza is large, thin crust, doesn't have pepperoni. Bake time is 10 minutes. That's correct for a thin crust. I should have labeled the output better, but the second pizza I created was thick, and therefore I had a 16-minute bake time, and the third pizza was thin again, so it had a 10-minute time. This is a very simple example, all right? However, it contains a lot of important concepts. Creating a class, attributes and methods, instantiating an object, that is creating an object, using the sets and gets to access and retrieve the values of the attributes, then finally calling a method to do some sort of calculation. Any questions on any of this? Now, your example, you're going to do something like, oh, go ahead.
So for the pizza class, how come the string is the string is capitalized but Boolean is not?
Oh, really good question. Why is string capitalized and Boolean is not? We'll get into this more later, but strings are objects. Booleans are what are called primitives. Notice when in my example, when I create an int was also lowercase. Primitives, there's a handful of primitives, and they're probably listed in the book. Int, Boolean, char, double, I don't know, a few others. Things that are primitive are very basic pieces of data. They just have a value. They don't have methods associated with them or attributes. Strings, however, have attributes and methods associated with them. In fact, we saw one of the methods, the equal method. So if it's an object, capitalize. If it's a primitive, lowercase. Now for your homework assignment, you have to take that chart and create a student class to do that. Now, it might seem a big leap from this to that, but really the main difference is going to be that calculate tuition method that you're going to put in there. Because what are you going to have? You're going to have two classes. You're going to have a unit test class and you're going to have a student class. All right. What's your student class going to contain? Well, it's going to contain the attributes that you need. What are the attributes that you need? Well, you probably need a name. You need the residency code of the student, right? Because that's relevant in calculating their tuition. You remember, in-county got one charge, out-of-county got another charge, and out-of-state got a third charge. You're going to need to know the number of credit hours that student takes. So your attributes will at least contain those three things: a name, credit hours, residency code. You're then going to have a method called calculate tuition. All right. That is going to evaluate in a series of if statements to see what type of student they are. All right. Whether they're in county, out of county, or out of state. Figure out their tuition rate and then multiply out to get the correct value. Except there's a little catch. And that catch is the 13 through 18 credit hours, you're all charged the same. Okay. This isn't due till next, we won't have class. I have posted a video in Canvas that talks about this. So review the video. Should be of assistance to you.
Would you be using like a constant variable if statement for the 13 through 18?
Yes. Yes. Watch this in week 3, which is now available. Review tuition calculation. I made that a previous semester, but it's still relevant now. This also talks about Java primitives versus references in week 3. So I may have gotten ahead of myself a little bit. I will post along with the stuff that I posted in week 2, more information about objects and classes to compensate for the stuff that got omitted at the beginning. And I do apologize for that. Those of you that are watching the recording of this, about 15 to 20 minutes of the class got chopped off because I forgot to record. So I will post material that covers that to the week 2. So when the lecture video goes up for week 2, I will also at the same time post links that describe what classes are, what objects are, what business logic classes are versus GUI and data access classes, and so on. Does anyone have any other questions? All right, that's all I had today. Have a good Labor Day weekend, and we'll see you the week after next.